Guys, welcome back. My name's David, and we are going to be continuing on with a deeper dive into Netcode for entities. Last time we talked about RPCs and communicating with the client and server world. This time we'll be talking about ghosts and spawning actual game objects into our scene. So, the difference between ghosts, which are basically the network objects of Netcode for entities, and RPCs. If you are familiar with Netcode for game objects, the ghosts are your network objects. They are persisting in your actual game scene, with all of its components being synced up automatically for you. So for Netcode for entities, ghosts are server authoritative. That means that everything is controlled by the server and the clients are just replicating that. So your clients themselves don't actually have any input to say where objects actually are. All they will end up doing is sending input data to the server. The server will simulate everything and then spit back out the updated game state to the clients. Now, the clients are also running a simulation themselves, and this is where we get into the client prediction and reconciliation. We'll get into that a few videos later. We'll get into like physics and how the simulation and rollback works. So I guess we can get into like the main differences between using ghosts versus using RPCs. Like technically you could use RPCs for everything, right? Every time you press a button, you'll send an RPC to the server will do its thing, right? But for RPCs in general, those are more for like one-off events. So if like a light turns on and you send an RPC, then anybody joining late will miss that RPC command and that light won't be switched on or off. With ghosts, it will persist. So any late joining clients will automatically get the latest state. They call it eventual consistency. So we'll actually get into what that actually means here in a second. So the way that the ghost system works here is that there is a snapshot system that will automatically send out updates to the clients every network tick. And that update includes all the changes that has happened to the world state since the last tick. And there is various optimizations. There's like delta compression and diffs that we're not going to get too into, but that just helps to keep the bandwidth low. So I guess we should just get into some examples here. Here in the editor, to actually make a ghost, you'll first do it in the game object world here. So we have a prefab called player. We have a player authoring script, which basically just puts a player component onto this entity. We have our player input authoring. We'll probably get into input, probably keep that to a separate video here. The linked entity group authoring here, what this will do is this will keep your player, this game object, tied to your connection or whatever you actually link it to. We're linking this to our connection so that when the connection gets destroyed, when you disconnect, it will automatically destroy the player as well. Finally, we have the actual ghost authoring component. And we get a cute little icon for it. So here we've got a couple of fields that we need to set here. The importance is basically a weighted value on the urgency of this update. So like it says here, if a importance is set to 100, then that means it is 100 times more likely to be sent than something with importance of 1. So for something like your player, you want all the players to be updated with a high priority, right? Everything with a lower priority, when the snapshots are going out, if the queue gets filled up and there's not enough bandwidth to actually send out everything at once, it will send out the higher importance data first, and then it will filter down through the lower important stuff. So things like your player, like with its health and stats and all that, you want those sent at a higher priority. Things like, footsteps or bullet holes or whatever, or something far away. You can have, there actually is a system that is distance-based importance. There's a whole ghost distance system. I don't know if we'll get to it in this video or not, but things that are farther away will get less important. So things closer to you, you want that to update quicker. Things farther away, not so much. The ghost modes here, we have interpolated and predicted. So interpolated means that you are getting your updates from the server, and then you are interpolating your current state to whatever state that the server just said it was. This will be for remote players, like players or objects that you don't have less control over. For predicted, this would be like your actual player character, right? So what this will do is that it will update locally on your client first, and then if when the server updates and tells you where you actually are, then that's when you'll have a rollback will kick in, and then it will roll back a couple of ticks, reapply that state, and then resimulate back up to current to correct any mispredictions that you had. So this is kind of how it will hide latency from you. So when you're predicted, that means that all of my inputs for my character go through immediately. And then if there's any discrepancies, then it will roll back and try to correct those. We'll get more into that a couple of videos from now. And then there's all. The optimization modes. So for the optimization modes, we have dynamic and we have static. For dynamic, this means it is going to do kind of the full suite of optimization. So you'll have your delta compressions and the diffs, which just means that only like the bits that actually change from the last tick will get uh, sent over the network. But what that means is that you'll need to do potentially more rollbacks if things go wrong. For static, nothing is actually going to be sent across the network until it changes. So for something like doors and like level geometry and stuff, that's mainly static, but can potentially change state. When it changes, then like the entire struct will get sent over the network for a new base state. Then after that, nothing will get sent until something changes again. So for stuff like your player, you'll want to keep those dynamic. But for like level stuff, you probably want it to be static. And then has owner, this is the owner of said object here. If it doesn't have an owner, then it is going to be basically owned by the server. For your player, you'll need to have this checked. And once we create the player, you have to assign this network ID as an owner. The auto commands, we might get to this in the next video, but for auto command targets, this is how you get your inputs. So we'll go over that in just a second, but there is a special struct called iCommand data, and I think there's an iAuto command data that will automatically get streamed to the server. Just every tick, it will send out the input, and that way the server will automatically apply that input to whatever you have as the auto command target. So for this ghost player, we will set our auto command target to this object. So it knows whenever it receives a command data from us, it knows how and where to apply it. The track interpolation delay, we're not going to get into this, but this is also for the lag compensation. So you know exactly how long it's been since the last update to roll back to. We'll probably end up getting into this when we start going into the client prediction stuff. The ghost group, we won't get into now, but this is basically for parent-child relationships. So if you have a weapon that is going to be carried by the player, you want the weapon position to always be updated with the player position. So even if it's of like lower importance or whatever, you want all of this to be sent at the same time. If the packet gets dropped or whatever, you just need all of these to be sent without discrepancy there. And then finally, the pre-serialization. This, like it says here, for gameplay items like a ball for players, for like a football or soccer ball, this will always be sent out no matter what. Like I said, it needs to be set at least once to at least one connection. All right, so let's get into our actual scene here. All right, so to actually get our ghost into our worlds, you need to put it into a subscene here. So to create a subscene, you basically just right click, new subscene, and it just be an empty scene. Anything that's loaded up into a subscene will get automatically baked into an entity. So our plane here, which is just going to be the ground, all of these components will automatically get converted into entities with entity components to match. Here is our player, and basically all we're doing here is dumping this kind of prefab here into a entity that we can then read from and spawn as many as we like. So when you're instantiating a ghost, it needs to already exist in the world, and you're just basically copying it. We can look at the code here. This is just standard entity stuff. We have our player component data. It's empty. So we are going to have our player authoring mono behavior that's actually going to be on the prefab. The baker here, this system, is new to the Entities 1.0 system. Before there was like an attribute for authoring that would basically do all this stuff for you. But now it's just a subclass, which is a baker, which will create our entity and then add all of our components to it. And this happens when the scene loads up for the first time. This is our player prefab, which is going to take that entity that we just authored over here and drop this into another entity that we can actually spawn from here. All right. So now that we have these entities in game here, there is a special RPC that you need to send after you've connected in order to kick off the Ghost Snapshot system. That's not actually going to run until this network stream in-game component is detected. So basically what we'll do here is we just have a go in-game system for our client. This is using iSystem, so it's a struct. With iSystem, we can use the burst compiler for all of our functions here. It's technically not doing much for us right now, since this is just going to be running once for one entity, really. And but it is slightly different syntax here than what we've seen before. We still have the require for update queries that we just want to do this for any network ID that does not already have the network stream in-game component. And what we're going to do here, we also, as soon as we connect in-game, we're just going to instantiate a prefab. This probably could be its own system for spawning and respawning players, like when they die and whatnot. But for now, we'll just do it here on connection. So here on update, basically the same thing that we've done before. We've got a command buffer. This one we are just creating a new command buffer rather than using like the begin system simulation group that we've used before. We're just calling it here, and then we're just immediately running it after we grab our network ID and make sure that it does not already have the network stream in game. We're going to add it to our network ID. Then we will create a new request for go in game, and then we just send it. Just a regular send RPC command quest. We give it the target and connection, which is, since this is the client, this is going to be the server. So we're just sending it back to the server, and there we go. Then we play this back immediately. Here is separate system. This is the go in-game server system. Again, with the first compiler, make sure it's only on the server simulation. Here, we're getting our lookup table again for our network IDs. And then we are just going to be going through looking for this request, receiving the RPC command request. We're going to need our player prefab that we saved from the player prefab authoring. And then we grab the actual network ID. So here we have the system API get singleton. So when you know that there is only going to be one entity in your world, you can grab this get singleton to just grab a reference to the player prefab entity, and then we get our player that we had authored at the very beginning here. So we cache that off, and then this is going to be what we use to instantiate our player. So again, we grab or create our entity command buffer. For here, I don't remember if we did this in the system base, but this network ID from entity is our lookup, and this just makes sure that we are fully up to date here. So if any new connections have connected and whatnot, we just make sure that we are up to date there. Here we have our for each again, which is just getting a reference to the receive command request. And we just make sure that we are getting our go in game request with entity access. Here, we actually add the network stream in game to the connection that we just received this from, so our client. We will grab the network ID again from our lookup from the connection we just got. Just a little debug log here just to show that everything's all kosher. And here we instantiate. So this is just the entity command buffer .instantiate. This will create another entity with this prefab as kind of the blueprint. And we'll save that out to our player. Here, important part, our ghost owner that we had checked in the inspector, we have to set this to our network ID, so it knows that the owner of this player is us. And then here, this append to buffer we will add this linked entity group to our connection. So this will link our connection to the player. So whenever the connection goes away, so will the player. Then we just destroy the request. We don't need that hanging around anymore. And then we play it all back. So we can see that here. Go back to our main menu. Make sure we are going to our game scene. Right, start host. So we have our, well, you're not going to really see it here, but here in our entities hierarchy, you can see our prefab here, which is what we are using to spawn our player here. You can see the prefab ghost here is the filled in prefab icon here. It's blue normally, but I've tinted everything. And yeah, so we have successfully spawned a player. We can go in and add a couple thin clients, and we spawn 2 more here and here. We can, maybe it'll let us move this around. Yay. Here, and yeah. And we can move this back and forth. So yeah, that's basically the rundown on ghosts and how to spawn them. In the next video, we'll get into player inputs and moving these dudes around. There is also, we'll probably get into ghost component data. We might get into that next time as well too. But yeah, that will keep it short and sweet for now. And if you guys have any questions regarding this, definitely leave a comment and we'll try to help you out here. All right, see ya.